the 12 years he was in Alaska living with grizzly bears. It's an amazing movie. But Werner makes him a real human character with faults and strengths, and instead of just being a stereotype.
That's amazing.
Yeah.
I got to watch that.
It is great.
Well, you've written a lot about in the past about
and
climate.
you can watch Werner's other movies that I'm in too, by the way. No, just going.
Anyway. Right, we'll plug them.
Anyway.
You've written a lot about climate change and that argument there, and I'm thinking about that because it's at the heart of a few things we're talking about. It's at the heart of how the planet evolves and how it can destroy itself. It's at the heart of humanity and whether or not we destroy ourselves in it, and it's also at the heart of the scientific issue that we're having right now, where sometimes it has to be, or a lot of times now it has to be everything or nothing, and you either have to think that the planet's going to die tomorrow, or that it's not dying at all, and you deny it. How do you rectify this in our current landscape? Like when you talk about climate change, what are your thoughts there, and what are we looking at?
Well, I wrote a book about it, but I mean, look, climate
Link
change
in description.
My book is most importantly, I actually wrote it partly for a friend of mine, magician Penn Jillette, who's a kind of a libertarian, and he wants to know, and his point is that I don't want to be told what to do. I want to know what the facts are so I can make my own decision. So I wrote a book about the physics of climate change, which doesn't have policy recommendations. It's just so anyone can understand, because it's not rocket science. The fundamental physics of climate change is 200-year-old physics that we understand, and it works. And so I wanted to explain how it works. So climate change is happening, and it is anthropomorphic. It's human induced, and it's happening. And there's certain implications that are unambiguous and undeniable. There are other things that are more speculative. One of the things that is going to happen, no matter what we do with fossil fuels, given the amount of additional energy that has been absorbed by the Earth due to the increase in carbon dioxide over, say, the last 25 years, the oceans have heated up by something like 0.007 degrees Celsius, something like that. But the amount of heat in that is the equivalent of something like 3.5 billion Hiroshima-level atomic bombs. 5 every second, 24 hours a day for 25 years, okay? Now, there's a fundamental property of water which isn't quantum physics. It's high school physics. You heat water up, it expands. Now, when that heat is equilibrated in the oceans, it causes the oceans to rise. Sea level rise isn't just happening because glaciers are melting. The sea is getting hotter and it's expanding. And just due to the expansion of the energy we put in over the last 25 years, no matter what we do, sea levels are going to rise by about 1/4 of a meter in the next 25 to 50 years. Now, that may not seem like a lot to you, but when you consider that maybe 100 million people on Earth live in places that are less than 1 meter above sea level. I mean, I wrote the book after visiting the Mekong Delta in Cambodia and Vietnam, which is like a perfect storm for climate change. 50 or 80% of South Vietnam is less than 1 meter above sea level, okay? And the Mekong River, which now supports 60 million people with fish and everything else, it keeps out the salt water because it's strong enough and to keep the salt water from impinging on it. And when sea levels rise and that salt water overwhelms the Mekong, those rice-rich deltas that are the most productive rice-growing regions on the planet are going to turn into mangrove swamps, and so those kind of things are going to happen.
How do we fix that?
Well, we don't. I think things that are going to happen we can't fix directly, but we can. Technology can do a lot. The big problem of dealing with climate change is not technology; it's politics. Okay?
Of course.
For example, Holland. Have you ever been there? I have. It's a wonderful place. Most of it's underwater. Would be underwater if it didn't have dikes. Okay. Holland is a beautiful place to be, but if technology hadn't intervened, much of Holland wouldn't be there right now.
Our Discord and Patreon links are in the description. We are starting to do AMAs on Discord, and we are also now releasing a new show called The Julian and Alessi Show with my producer, Alessi Alaman, on Patreon, along with some other exclusive content from episodes that we have been putting out on YouTube that are not seen on YouTube.
And so there are ways to do it, but you have to have the foresight and willingness to address those technological challenges and the money. And the problem is, most of the places that are going to be affected are the places that didn't produce the climate change in the first place. But and if we want to help things, then the first world is going to have to spend a lot of money on the third world, which ain't going to happen, unfortunately. And if it doesn't, the problem isn't going to just be, in my opinion, the problem isn't just going to be a lot of people losing, being flooded out from where they live. It's when you have not just 1,000 or 100,000 climate refugees, but you have 100 million. You got to wonder about the socio-political impacts of that.
Oh, it's a lot.
Yeah, and whether that's going to cause a war, that's going to cause, in the Sudan, for example, a lot of the problems in Sudan happened because of a drought where people moved from the countries to the cities, and that eventually produces civil unrest that caused a... And so the indirect socio-political impacts of that are potentially tremendous, and I view those as much more serious than the physical devastations or negative impacts that may come from climate change.
Yeah, I think to your friend Penn Jillette's point, I think the issue a lot of people see with it is, and it's hard to talk about this topic with people these days.
Yeah, it's hard to talk about a lot of topics.
Exactly, but if you're nuanced, we're finally getting used to that. Yeah, okay. If you're nuanced on it, like I would like to think I am, it gets difficult to pose these questions, but how do you do it without kind of virtue signaling in the first world to feel like you're doing something when in reality what you're doing is just telling people, oh, you got to use this fucking bendy straw that no one wants to use, and that's going to save the turtles?
Well, look, I try not. I do try to tell not to. I try to provide people evidence and knowledge and hopefully encourage them to make their own decisions. So I try not to tell people how to live. I'm a vegetarian partly because of reasons of climate change. But there are other reasons. But there's no doubt that if more people in the first world ate less meat, there'd be less carbon dioxide put in the atmosphere, for example. But
then there'd be more.
What?
There'd be more available in the wild that would still get eaten. Well, okay, all right.
It's a complicated issue.
Yes.
Okay, but there are questions that you're worth asking. So, when the problem with climate change, you hit the nail on the head in the sense is all of us seem so tiny that how can any of us impact on climate change? What can I do? And the answer is, yeah, there's some things I can do. I can, eat meat. I can maybe travel less than I do, or something like that. But what I can do is try and educate people about the reality of it and the potential actions we can take. There's an old saying that if the only tool you have is a hammer, everything looks like a nail. Mm-hmm. I'm an educator. And I happen to think that an educated populace produces a better democracy. So I can educate people, and they can maybe elect politicians who actually base their policies on empirical reality instead of bullshit.
But what politicians aren't owned by corporate?
Look, you can say it's never. Look, what is true is whether you have a democracy or a dictatorship or a oligarchy or whatever, governments eventually respond. When you have more than 3% of the population that's actively willing to act on a certain issue, governments respond. Governments never lead; they follow. And so what you can do is, if it's in the interests of, let's say they're bought by the corporations, when it's the interests of the corporations to behave a certain way in order to appease the public, they'll do that. Okay? And so what you can do is educate people, and when enough people are aware of the situation, that if you're a politician, then acting in a certain way is not going to get you elected, you're not going to act that way.
Yeah, but there's also, look, people still are gonna operate on the how do I take care of my family? How do I get to do what I do? I mean, look, you're coming from science, right? You are coming from a space with some. Go ahead.
Okay, I get to, normally when I'm doing a podcast, people hate when I interrupt, but I'm the guest, so I get to interrupt.
You do get to interrupt.
Yeah, and so here's the deal: what people do care about are their children and grandchildren. So you're right. I might not be able to say to you. And by the way, first thing I can say is that if we respond to climate change, doesn't mean we have a worse standard of living. It may means we have technologies that are even better. Some people like Tesla's better than
sure.
So it doesn't mean giving up our standard of life or other things. But what I can say is that your grandchildren and your children and grandchildren are going to live in a world where the sea level is maybe a meter higher. That means if you live in New York City, if we don't do a lot of stuff, if you live in Hoboken, forget it.
Well, this is already a fishbowl.
Yeah,
here.
Exactly.
Yeah.
So, and people are kind of worried about most parents would like the future of their children to be better than their own future.
Yes.
And their grandchildren. And maybe that's a way you get people to have their own myopic desires match with what can be what we need to do.
But there's always the syndrome of, it won't happen to the next generation. It's 3 generations away.
That's the same thing as evolution. It's hard. Long time is hard to is hard, and it's a real challenge. It's a real challenge, and whether we deal with it, it depends on the day. Whether I'm optimistic. I'm usually pessimistic, but as a well-known writer friend of mine who just died said, Cormac McCarthy said, I'm a pessimist. I asked him why he was so cheerful, because he writes very dark books. And he said, I'm a pessimist, but that's no reason to be gloomy.
I'm a pessimist, but
anyway, it's my mantra.
More on there.
I'm kind of a pessimistic, but life is.
You're more of a ball breaker. I think that's what you are.
I try to do that too.
Yeah, those 3 months in New York when you were a kid really rubbed off on you.
I think so.
They kind of stayed there.
Yeah,
but I at the core of it though is the simplest and most complicated thing simultaneously not in our world, but in our society, and that is it does come back to money. People are. I mean, you know how it is. Look, how many brilliant physicists are there out there in this country? A lot. Right? And you're one of them.
Maybe.
And yet, you guys, in order to do what you do, you have to have funding. Period. End of story. Mm-hmm. And you and all of your friends have had people over the years fund you. I mean, Epstein was a guy who funded a ton of physicists and everything.
But the dominant funding ever since
But you don't control that is the point. No, you don't control who does that.
But the government, well, here's the deal. Here's the way it's worked. And it's like democracy. It may be a crummer way of governing, but as Winston Churchill said, it's better than all the other ways. And so the kind of work I did, the particle physics, and even to NASA to some extent, is private industry can't fund it. It's just not enough money, and the payoff is not close enough. So the government has to fund it. The government creates agencies like the Department of Energy and the National Science Foundation. Those get run by scientists, and then when you do a grant proposal, it's peer reviewed by other scientists. And so the system. Now, that's not to say scientists aren't biased and all the rest of the crap.
It's not bias. It's that they still have to get funding on top of that.
So they have to lobby Congress to fund.
Who pays them?
Well, and the scientists, I've used to visit Congress people when I was more active in a university environment and explain to them what was going on so that they would know why certain things should be funded. And you hopefully try and convince them. But, of course, they're influenced by other things. And so there are biases that come in. But the system on the whole actually works. On the whole, good science has gotten funded. And we made progress. Just look at all the things that have happened. So you're right. There are impediments to rational and objective decision making, but the system, especially of peer review, has traditionally worked when it comes to the funding of science. And part of the reason is that science that you're not dependent on private industry. Now things are changing, and you are seeing billionaires getting more involved.
Yeah, it's been happening for a while.
Yeah, and you are seeing them, but you can try and convince them to act rationally too.
Well, it sucks because now society, with this open source world where this is great that we all kind of get to see things.
Well, we also get to see things that don't exist in an open source world. But yeah, I mean, the internet has been amazing, but there's more misinformation than there is information.
Absolutely. Okay. But what I'm saying is, every person has to answer for everything that they've ever been around, even if they're not around it. I have to sit there and I have to watch.
It's bullshit.
I have to watch guys like Pinker, like you, answer questions about Epstein and him funding stuff because he was one of the billionaires that did this stuff. And in reality, to me, what it's always looked like, obviously it looks a little different for celebrities and things like that. What it's always looked like is you have people who come in and say, "Oh my God, I love that you're working on the origins, Lawrence."
Yeah.
What's it going to take for you to be able to find X, Y, and Z? Oh, well, maybe 15 months. Here you go. You are incentivized to take that.
Well, the point is that would you rather have the people you don't like, whether it's Epstein or the Koch brothers, would you rather have them funding oil and gas industries, or would you rather have them funding people who were looking at the fundamental questions of the world? Would you rather have them spend money on good things or bad things?
Now that's a real poison pill question. That's an interesting question.
Of course it is.
But what if they're trying to use their funding of those good things to turn it into bad things?
Well, you can't look.
I mean, the Koch brothers did that their whole lives.
Well, you might say that about the government too. What if I pay taxes and the government's building nuclear weapons? Well, that's true. But maybe I'm also paying taxes so that I have healthcare and I have police and I have military that maybe is defense. So like life is just not. I can't control the world. It'd be great if I could, but I can't. What I can do is try and have a positive impact.
Absolutely.
And I can try and have positive impact by one of the things I can do is if I think the things I'm working on are worthwhile, I can try and convince people to support it. I may be biased and they can decide whether it's worthwhile. So that's all I can do, right?
Yeah. Is there a way to, even in the modern academic environment, though, because like historically we've always thought about the best research obviously happening in academia, but that includes students who are on the come up.
Yeah.
It doesn't just include the professors and things like that. Is there a way to foster a better environment so that we kind of have a more academic-led private side of society making progress here? And here's the second part to this question. Peer review, I agree, was actually at its outset a great invention, but do we also have a problem where peer review is almost shutting things down?
It is, absolutely. Absolutely. I told you, it's like democracy. It's the worst thing, but it's better than all the rest. I don't want academics to be. Look, many of my best friends are academics, or have been, and many people I know. And there are a lot of scientists I'd want to keep as far away from government as I can imagine, and so, and from the public, by the way, in the sense of they're just they wouldn't communicate well. But so look, I think all you can do is try and encourage people to ask questions, and keep an open mind about being guided by empirical reality, not a completely open mind, as the former publisher of the New York Times that said, I want to keep an open mind, but not so open that my brains fall out.
Oh yeah, that's a good one.
But so all I want to do when I educate people is encourage them to ask questions, and to be willing to change their minds. And if that happened more universally in our society, I think 95% of the problems in modern society go away.
Real quick, I just have to go to the bathroom. I want to ask you about inflationary stuff, though, next, so we'll get to that. We'll be right back.
Okay. Yeah, anyway, it doesn't matter, but I know him, and he's
he's
also supported, not my research, but he's supported some public things we've done once.
Well, actually, if we're back right now, before I get to the inflationary thing, because we were just talking about it off air for a second. So you have sat with Elon a little bit then?
Yeah, I've been with him a few times, yeah.
How long ago was the last time you were with him?
The last time I was with him was, we communicate by email, and last time I communicated by email with him was maybe a month or two.
Oh, really?
But the last time I was physically with him was a while ago, probably around 2000, well, probably at least 5 years ago.
How legit, based on, we know where he is, obviously, in pop culture and how people look at him as a genius and everything, and I certainly do too, but how legit do you think that is, and like the
What do you mean
work that
legit? He's done some amazing things, but like... He's done some amazing. Tesla, SpaceX are just amazing.
I agree.
Okay, people make the presumption that because people are extremely successful, they're also somehow extremely smart and know everything about the world. And the point is, they're very good at what they do, but it doesn't mean they're very good at everything. And so I know a number of billionaires who are under that illusion too. Just because they're billionaires, that somehow they can do anything. And the answer is they can do what they've done, and that's been very successful. But the same is true for science, the same is true for anyone. And so, I am skeptical, and I judge everything skeptically, and I'm based on the evidence. So Elon has done amazing things that I could never do, and brilliant things that I could never do, but some of the stuff he says or does is stupid. So that's just the way it is.
Yeah, he's definitely an odd communicator. And
well,
I think that's kind of the price you pay for it,
well,
right?
That's
genius.
Well, I don't know. There's people I know who I think are smart that also can communicate. But it's not just that. I think it's, all of us have crazy ideas. And if you're Elon, then some of those crazy ideas also, because you have a platform, be it publicized. And so you just have to filter what everyone says. Just because you just have to realize that everyone... It is wrong at times, right?
Yeah,
and I am too. I told you that one time 20 years ago.
Well, actually, speaking of being wrong, because this ties right into the topic of universal inflation, but I had a friend of yours, Brian Keating, in here recently, who also is responsible for us talking together.
Oh,
but
yeah,
Brian,
that's right.
I love talking with Brian. He's so enthusiastic about science. He's so much fun. But he's done a lot of amazing work in his life, and one of the things he has spoken and written about very openly is the fact that in some ways his granddaddy of them all project proved to not be what he was looking for.
Yeah,
and what he was looking for around 15 years was he was trying to prove from experiments in the South Pole that the universe was inflationary. And he felt like he posits that if you proved that the universe was inflationary, that would mean that the multiverse, which could mean a few different things, does exist. So what I wanted to ask you was, first, if you could just give people a quick rundown of what we mean when we say the universe is inflationary, and secondly, if you think it is.
Well, yeah. Let me say the idea that if we could show that inflation happened, I actually wrote a paper on this. I was one of the people who did.
You write about a lot of things.
Yeah, well, me and a Nobel Prize-winning friend of mine, Frank Wilczek, wrote a paper showing that if you could measure what they were looking for, we proved that if you could measure what they were looking for, you could have indirect evidence that the multiverse existed, which is the best we'll ever have. But it would turn metaphysics into physics, because you could show that we'd have indirect evidence that was pretty incontrovertible that there were other universes. And it's an amazing thing, but you can show that. We'd also be able to prove that gravity was a quantum theory. Those are the two implications of that paper.
And what do you mean when you say gravity is a quantum theory?
It means it's quantum mechanical, that the fundamental variables of space and time behave under the rules of quantum mechanics. And if that's true, by the way, you can create a universe from nothing. But anyway, inflation is the best fundamental theory it's the only, let me say not just the best, in my opinion, it's the only theory based on well-defined physics that's testable, that can explain why the universe looks the way it does, or rather how the universe looks the way it does, okay? Without inflation, the universe that looks the way it does now, that's 14 billion years old, seems absolutely impossible. But with inflation, it happens naturally. And moreover, inflation is a phenomena that would happen almost invariably in the early universe, given the laws of physics as we know it.
What do you mean by that?
Okay, so that inflation... Okay, we got to step back now.
Let's do it.
Yeah, I know.
Away.
Okay, yeah. Squeeze you with your hands. We're going to need to work hard. Okay, so inflation is based on the idea of what's called a phase transition. So let's say it's a cold day here in Hoboken. It's below 32 degrees. Okay, and it's been raining before that, and the ground is full. The streets are full of water, right? But the water isn't ice yet because it's rush hour. And the cars are traveling through and knocking the water around and stopping it from freezing. Then, after rush hour, suddenly the water freezes because it's below 32 degrees, and the preferred state of water below 32 degrees is ice. Mm-hmm. When it's below 32 degrees and the water really wants to be ice, when the water becomes ice, it releases energy. Okay? Now, so it's in this phase called a false, it's not in the true ground state. It's not in the state it wants to be when it's below 32 degrees and it's still water. The lowest energy state of water at below 32 degrees is ice. Mm-hmm. That's why ice forms, okay? But you can stop it from forming ice if you do things like stirring it constantly and things like that, okay? Got me? But because the ice is the lowest energy state, that means the water contains more energy than it would have if it were ice. And when it becomes ice, it releases energy.
Yes.
Okay? Got me?
Makes sense. Yep.
Well, as the universe cools down in the Big Bang, it can get stuck in what's called a false vacuum, a false ground state. It can get stuck, just like the water does, in a state that isn't quite the lowest energy state for a little while. Okay? And then it can release that energy, and everything can heat up, and you can have a Big Bang, like we've seen, okay? So if the universe exists in that false vacuum state, what happens? It means energy is trapped that would later on be released. Where does that energy exist? It exists in empty space. There's nothing there, but that space has energy. It's allowed, okay? But if you put energy in empty space, it's gravitationally repulsive, not attractive. You know from high school that gravity sucks. Right?
Yes.
Okay. When you put energy in empty space, it blows. Okay? It causes, and so that causes the universe to expand exponentially fast. And during a very short time, the universe can, an unbelievable, a time period of, say, a millionth of a billionth of a billionth of a billionth of a billionth of a second, the universe can increase in size by 40 orders of magnitude. It's incredible. And then if that phase transition happens and that energy is released, all of that energy goes into particles and radiation and heats up the universe and all the rest, and then the universe can evolve. That's inflation. It turns out if the universe expands by 40 orders of magnitude in that short time, you can explain why the universe is so uniform on large scales. You can explain why it looks flat today, why it has all the properties it has. So this phenomena that we think can happen naturally in any theory that has a phase transition, and most of our theories of particle physics involve such a phase transition, inflation will happen. The hard part is not getting inflation to happen. The hard part is getting it to stop.
Because and how would that happen?
Well, it turns out if we're right, in most of space, it hasn't stopped. There are little pockets of space like snowflakes that fall or raindrops. So you get a little pocket where the water condenses. In a little pocket, what's called a pocket universe in these theories, actually, the phase transition occurs locally. And when that little occurs locally in that region, you get a hot Big Bang. But most of space is still inflating. And that means other regions may not yet have had a hot Big Bang. And maybe at this instant, there's another universe that's leaving in the inflationary state and only beginning
a whole separate universe.
A whole separate in the sense that it's causally disconnected from us because the space between us is expanding faster than light. And
on a different time pattern.
Well, no, they're all in the same time. But it could be, but it might not happen now. It might happen a billion years from now. It might have happened a trillion years ago, and if inflation was happening on a large scale, and that means, and that's the origin of the multiverse.
Okay,
each of those.
Real quick before you go on, are you saying then that universe exists on a parallel plane of a similar idea of what we're doing, but it has a different outcome because it's on a different schedule? Or did I totally miss
sort of, but you're making it sound more metaphysical than it is. It's just a different region of a vast space, which we now call the multiverse, which had a Big Bang that happened earlier or later. And what you can also show in inflation is that when you leave this false vacuum state, the state you can go into can be different. It's like snowflakes. Every snowflake looks different, right? Mm-hmm. And so imagine the universe as being like all these multiverses, these different universes being like snowflakes that condense out of this background inflationary state, okay? That may go on for an infinitely long time, and that means an infinite number of snowflakes can form, okay, over time. But in each of them, the laws of physics can be slightly different. And if the laws of physics are slightly different in each universe, then you can say that some features of our universe that seem really strange, if the energy of empty space were any different than it is now by a significant amount, life wouldn't have evolved. Life wouldn't have formed. There would have been no life. So you might say, that's really weird. It looks like our universe was created so we could exist. But instead, you can think of it as a kind of cosmic natural selection. We exist in our universe because we can exist. It would be really amazing to find ourselves living in a universe in which we couldn't exist. That would be really amazing. And so it could be that life evolved to exist in a universe in which it can exist. There may be other universes that have separated out from that have condensed out of that background inflationary state, where the laws of physics are different, and no life can exist. There can be no galaxies and no stars. Or there may be universes with very different laws of physics where different things could exist and different kinds of life could exist. And so it's possible, but you get to the point where if there are, over an infinite amount of time, an infinite number of universes, then you have all this craziness that infinity allows. There could be a universe that exists where, everything is the same as our universe, and the Earth is here, but I'm interviewing you instead of you interviewing me.
Yes.
Okay? And when you allow for infinity, anything can happen, but that's kind of metaphysics,
Okay, well, let's get into the deeply theoretical then, which is, obviously completely, in any way, not even proven fake or real or anything. But, I've heard you talk about the multiverse as two potential separate ideas. A multiverse, and I may mess up the language here, so just correct me afterwards, but a multiverse that unlocks all the way up to 11 dimensions or unknown dimensions, or a multiverse that exists into a fourth or fifth dimension that just has all kinds of, I guess, onion-like layers to that dimension. That's
a different multiverse.
Okay? Yeah, exactly. Right. Can you unpack that?
Yeah, well, the multiverse from inflation I view as incredibly well motivated, because inflation is likely the explanation of how the universe became to look like it is here now. And if inflation happened, there's almost certainly a multiverse inflation produces. That's one kind of multiverse. That's different universes that are separated in space by an amount farther than we can ever see.
Is it like the multiverse that, say, Philip K. Dick wrote about in The Man in the High Castle? That type of thing, where it's different realities of the same set of circumstances?
No, that's well. I mean, not really. In the sense that these are just different universes in different space. You draw a big map of the multiverse. There's a universe here. There's a universe there. There's a universe here. The universe there. They might be different. They might be the same. If there are enough of them, yeah, there could be two of them that are almost identical. Okay, but they're separated by distances larger than light will ever be able to travel, and therefore they're never connected. They're never causally impacted by each other. But that's just different universes separated in three-dimensional, four-dimensional, but three-dimensional space. But the universe you're talking about, which is the multiverse you're talking about, arises in theories like string theory, which assume there are extra dimensions, for which, by the way, we have no evidence whatsoever.
Right.
Okay? Important to point that out. But if there are extra dimensions, then, yeah, if there are 7 dimensions and we live in a 4-dimensional universe, then, then in an infinitesimal distance in that extra dimension at the edge of our nose in another dimension, there could be a whole other universe that has, that may be 4-dimensional, maybe 7-dimensional.
Is that where the idea of where it's like tuned just right that I was talking about a little bit ago?
Well, the idea comes in both. If you have many universes and the laws of physics are different in those universes, then this idea of fine-tuning happens naturally. It's called the anthropic principle. The idea is if there are many different universes and the laws of physics are different in each, it's not surprising to find ourselves in a universe which looks like it's fine-tuned, not because the universe is fine-tuned for us, but life is fine-tuned for the universe in which it exists. Just like Darwin.
Yeah.
It looks like life is fine, that the Earth is fine-tuned so life can exist on it. Well, it's the other way around. The life evolved because it could, and the only life forms that don't go extinct are those that appear perfectly fine-tuned for their environment because they know how to get food and they know how to reproduce. It looks like there was divine creation, but instead it was the finches evolving to have the right beaks to be able to get the prey that they needed in the island and the Galapagos that they lived on.
If that were proven to be true, would it be possible, in your estimation, I guess theoretically, completely,
yes,
to traverse across?
No. In string theory and in the inflationary multiverse, those universes are separate and essentially forever will be.
So
there's
you
no
would
way.
not
There's
have
no.
it would, like what Philip K. Dick wrote about, would not be possible.
No. Just like the many universes in Star Trek. You know, in quantum mechanics, some people like to talk of many worlds theory. It's usually bullshit. But I mean, the language is the idea. I know where it comes from. But the point is, you never can jump between those. It's a law of physics that you're stuck on one quantum trajectory.
So are you saying there's no such thing as time travel? That's making a stretch.
No. I'm saying it's extremely unlikely.
Extremely unlikely, but that's not a no.
But I don't need another. One of the resolutions of the time travel grandmother paradox is that I got to go into another universe. Right? The grandmother paradox. You go back in time and kill your grandmother before your mother was born. I don't know why you do. You're sick. But
that would create a different.
But hold on.
Okay.
Yeah. But let me explain to people who don't know why that's a problem. Okay. You kill your grandmother before your mother was born. That means your mother was never born. But if your mother was never born, then you were never born. If you're never born, how did you go back in time and kill your grandmother? Okay? That's a problem. Gives you a headache if you're a physicist. Okay? That's why most physicists don't think time travel is likely. But one of the possibilities that's been proposed as way out is somehow when you go back in time and kill your grandmother, you end up in a different reality than a different plane of existence, if you want, than the one before you traveled in time. So in that universe, it's like all the Star Trek episodes. You change the future, you change the past, the future changes. You come back to the future, it's a different future. Okay, and
see that's where you have an issue.
and that that, and who knows, but given the laws of physics as we understand them, time travel is extremely unlikely. I wrote about this in my book, The Physics of Star Trek, and Stephen Hawking wrote the foreword for that book for me, and he had
Shout
said,
out Steve, R.I.P.
He had said that time travel is impossible because we'd already be inundated by tourists from the future. In fact, he had a party
But
once.
would you know it?
Well, here's what he did. He said he had a party, and he invited tourists from the future to it. No one showed up.
What if they? What if they did show up?
No, but they didn't. And so
how do you know they didn't?
Well, because
Can you prove it?
They didn't have any. No one drank the punch. But
or did they? And it still remained gravitationally
I came up with a better argument against it.
Okay,
let's
hear it.
You can't say time travel is possible because because the tourists of the future would all go to the 1960s and no one would notice. You weren't around in the 1960s, but I was.
It was a hell of a time, I heard.
Yeah, I know. And so that would be the play. They wouldn't want to visit now. They'd visit the 1960s, and no one would have noticed if they were weird. And so, but anyway, the point is, time travel produces a lot of paradoxes that physicists haven't resolved, and we don't have any. And all of the theories, as we understand them, don't allow you to create a configuration that would allow time travel, even though general relativity allows for it in principle. And the question is, do the quantum properties of gravity allow you to create the conditions of time travel? And the answer is we don't know. It's an open question. So it's not impossible.
But if you go, so I had the great Michio Kaku in here, who I know you're a huge fan of. But if you look at the way he talks about like the Abraham Lincoln experiment, it's very similar to what you're talking about with your grandma thing.
Yeah.
But he's like, theoretically, it would have to be some sort of, or would most likely be, I should say, some sort of river of time, in the sense that if you could do it and you went back to Ford Theater in 1865 to stop Lincoln from being shot, you would not be changing the reality in the part of the multiverse that you come from. You'd be changing the reality of a different, now separated,
it
infinite
sounds good,
universe.
doesn't it? Like a lot of things people say, but it doesn't make it right. In fact, there's no good argument that I know of that
There's no good argument for
that. That doesn't mean
it's all theoretical.
Well, it involves physics that we don't understand, and it's totally unmotivated, in my opinion. So yeah, it's possible, but maybe pigs can fly.
I need Lawrence and Jack Sarfati in a room before
no, you
I
don't.
die.
No, you don't.
I need it. I need it injected in my veins. The two of you would be incredible. Have you done that with him before?
No, I'm on a mailing list that he will not take me off of.
He has the best Twitter. He'll take emails that like were big back and forths and copy and paste the entire thing and send it as a tweet. It's the greatest thing ever.
I did ask to be removed once, but I never did.
My buddy Danny Jones went out to San Francisco with him a few months ago and did a 2-part podcast. It was one of the most incredible things I've ever seen in my life. But that guy, you don't remind me of him, like how you guys communicate. I knew you'd say that. But some of the excitement you'll get or upsetment you'll get at certain things in science, that part's a little bit similar. I just think it'd be funny because you guys would have some obviously very different ideas about how things are. So it'd be good to
and
get
I'm
you in
right.
the room. And you're right. He'll say the same thing. He'll be like, "Fuck
Of course
you.
he will.
Fuck
of course
you.
he
I'm
will.
right."
Yeah, of course he will. But anyway, people can be entertaining, but that doesn't mean they're right.
That's true.
Okay.
But
and you should, and that works for everybody, myself included.
Sure. But when you're talking about this stuff, it does always go to, especially now with Twitter and the internet and everyone wondering about the meaning of everything and asking questions about what really is. All these questions of the multiverse and how it could work or things like that, they do always come back to aliens and extraterrestrial life.
Well, and for some people, they always come back to it. They don't for me, but anyway.
Well, they don't. But they don't for you.
Well, no, they do in the sense that we live in a big universe. So is there likely to be life elsewhere? Absolutely, it's just not coming here.
Why do you say that?
Because everything we know about physics says there's no reason, there's no ability to do it, no reason to do it, and no evidence for it.
But it's everything that we know about physics. What if there's
No, you don't understand. Here's the point.
Okay.
There's a lot we don't understand about the universe. More we don't understand than we do. But there's some things we do understand. And what people don't realize is that no matter what we learn about the laws of physics a million years from now, if I take a ball and let it go here on Earth, it's going to fall according to Newton's laws. Doesn't matter what I know about quantum gravity. What is important is that the new physics that we learn in the future will not contradict the stuff that's already survived the test of experiment. It may mean that we have to refine it. So sure, Newton's laws have to get refined when you go very fast. You need relativity. Or when you go to the very small, you need quantum mechanics. But on the scale of you and me and the Earth, cannonballs will always be described by Newton's laws, as will rocket ships. So nothing about quantum gravity that I learn will suddenly say, yes, I'll suddenly know that when I release this ball on the surface of the Earth, it's going to fall up. That ain't ever going to happen.
Never.
And so
we couldn't change it in some way.
Because because to do so would contradict the experiments that have already validated. So here's the idea. So when people say, well, physics that we don't understand could change everything, it isn't going to change the stuff that we know works. Okay? And it isn't going to suddenly say I can travel faster than light, or better still, it isn't going to say that balls are suddenly going to fall up. It's not going to allow you to create configurations that violate the known laws of physics. They can violate the unknown laws of physics, but they can't violate the known laws. And that's why in the physics of Star Trek, and a book I wrote afterwards, The Beyond Star Trek, I talk about, for example, one of the ways people think they see an alien spacecraft is they don't behave like aircraft, like conventional aircraft. They suddenly make right-angle turns and are going really fast. One of the ways you might know that you saw an alien spacecraft is it behaved exactly like normal aircraft, because those obey the laws of physics. If I were traveling twice the speed of sound and I made a right-angle turn, the G-forces you'd experience would be the same as about what you'd experience if a plane a few thousand feet above the Earth's surface suddenly lost power and crashed into the Earth. The moment it crashed, the G-forces would be the same as you'd experience in that. Planes don't look good afterwards. Now you might say, okay, well they have advanced materials. They don't.
Materials.
Okay, yeah, but maybe the aliens inside. Forget the materials. The aliens inside wouldn't look very good. I mean, in the physics of Star Trek, I pointed out that every time Jean-Luc Picard said engage, he was committing suicide, because even he wasn't traveling a warp drive, just impulse drive. Let's say you're in a Tesla. And I'll get paid by Elon Musk for saying that word.
All right. Yeah.
No, anyway.
I hope he's paying well.
Yeah.
He can afford it.
Yeah, anyway. Let's say you're in a Tesla and you're in ludicrous drive, okay, which I've unfortunately been in once. But and you get pushed back in your seat, right? So if I'm accelerating forward at the same rate as I would accelerate downward if I jumped off a chair, okay, I would be pushed back in my seat with a force called 1g, equal to my own weight. Mm-hmm. If I'm accelerating at twice that rate, I could push back with a force of 2g. So I would feel as if I was twice as heavy. Okay, 3g's, I feel like two people were sitting on my chest, okay? Some people are used to that, others aren't. But the point is that's about the maximum rate of G forces that people can experience for a long time. Up to 10 G's before you go be unconscious. The Apollo astronauts appeared, but the space shuttle astronauts 3 G's. Okay.
But what if they've figured out things that can
just hold on a second.
All right.
Okay.
I'm holding.
This is a force, right? So 700 G's is like a 35-ton weight hitting you. Okay.
That's a lot.
I can tell you that no matter what you tell me about quantum gravity, if I take a 5-ton weight and I slam it into you, you're not going to be talking to me about quantum gravity after it happens.
Right.
Okay? And so that's the kind of stuff I'm talking about. So why would you invent something, even if you could, that would effectively destroy everything in it? What's the point of having a sudden right-angle turn except to get people to make interesting UFO stories? Okay? And not only that, if you're developing an alien spacecraft to come visit the Earth for some reason, since no one knows we exist beyond 100 light years from now, 100 light years away, because we've only been emitting radio signals for 100 years or so. So no one on a star more than a few hundred light years away knows there's intelligent life on Earth anyway.
But they could want to go out and look if they're way far ahead.
Yeah, I know. Yeah, I could look at where it's a big galaxy.
Right.
So let's say
huge.
by accident they stumble upon us, right? They've built a spacecraft that spends 99.9999% of its time traveling through space. But they develop something like a flying saucer, which is meant to be aerodynamic in the atmosphere of the Earth, which they didn't even know was there till they get here.
But
why
what if
would they
have
design
other things that they could simulate to do that?
But why would they design a spacecraft, a flying saucer, if you wish, which is not the most effective way of traveling through interstellar space? Why would you develop an object that's perfectly designed for our atmosphere if you're just randomly building? Look, the NASA at the time, or the Elon Musks of the time, are not going to spend their money fine-tuned to develop something for a specific system that they don't even know exists. They're going to develop a rocket that is best designed to travel through space.
Unless they do know it exists because they have access to it and we don't.
How do they have access to what?
I mean, Elon's funded by the government.
No, but the point is, the laws of physics tell us. Here's the thing: if you wanted to travel to the Earth if you wanted to build, use warp drive, and there it looks great. Okay, fine.
What is this? The Nimitz? Yeah. That you're pulling up the video on the screen.
Yeah, great.
So how do you explain this?
I don't have to explain it.
Why don't you have to, Lawrence? You're here. You have to explain it.
I can just say that whatever it is, it ain't an alien spacecraft because any possibility other than an alien spacecraft, given the laws of physics as we understand them, is more likely. As Richard Feynman once said, aliens and UFOs are more likely due to the known irrationality of humans than the unknown rationality of aliens. Because anything I could see...
Wait, say that again?
Aliens, UFOs are more likely exist in our minds due to the known irrationality of humans rather than the unknown rationality of aliens. You can see things that are strange. I could do the magic tricks I was going to do for you, and you would see things that are mystical and amazing, but I could tell you they're not happening. You're just you're fooled. Seeing is not believing. Seeing is not the best evidence that something really happened. Okay? You have to do other tests. And there's no empirical evidence whatsoever that aliens have visited. I know you're turning it down because I'm speaking loud.
No, it's good.
But there's no empirical evidence that we've been visited by aliens. Moreover, the laws of physics as we know them tell us it's incredibly unlikely. If you wanted to travel here in a spacecraft like that, at anywhere near the speed of light, from a distant star system, you'd have to harness more energy than the power output of the sun. Okay. Now, let's say you could do that. Would you come here all this way, harvest the power of the entire sun, to come all the way here just to abduct psychiatric patients of a Harvard psychiatrist and do weird, kinky experiments on them?
I have very, very, very strong feelings about a lot of the experiencer stuff.
Yeah,
and I think even if you look at some of like Dr. Gary Nolan's work and stuff like that, there's some explanations there and everything that don't have to be aliens for sure.
Not only just anything, swamp gas. Give it any explanation you get, a weird reflection from the sun or a balloon or something that looks like it's a weird angle and you capture it and appears to be going faster than it is. No matter how ridiculous the explanation, it's like the magic bullet and it killed.
Yeah, ridiculous.
But almost anything else is more ridiculous. And so let me tell you, anything else is less ridiculous than assuming it's aliens.
Yeah, I know what you're saying.
So it's just things are likely or unlikely. And I'm a scientist and I say, almost any explanation I can come up with is less ridiculous, given the laws of physics that I understand.
Right,
than saying
the laws of physics that you understand.
The laws of physics that have been tested, that we know, given the known laws of physics. But I repeat to you, your mistake is to assume that the unknown laws of physics violate the known laws of physics. That doesn't happen.
But how do you know that doesn't happen?
Because they would be violated now. If the unknown laws of physics told me a ball fell up, every now and then I'd let the ball go, it would fall up. Okay? It's not what I learn about is not going to change what has survived the test of experiment.
But what if it is falling up and we just don't know it yet?
You know, there's a bridge I could sell you going to New York, and I can sell you for $1 million this bridge if you want to buy it. Okay? You can have it. You can put a toll booth on it. You can make tons of money. Just give me $1 million now, and it's yours.
Okay. So what do you think then of all this? Because by the way, I'll show my hand here. I do have some. You know, my tingly senses are going off with some of the disclosure stuff we see.
Disclose. Yeah, you should. That's the other thing that makes it implausible. More implausible than laws of physics. That our government could hide a secret like this for 50 years when any one individual could make $1 gazillion by throwing a piece of evidence. Yeah. Not talking about it to Congress or saying that you heard about it from someone else. But if if you think our government could keep a secret like that, I know how the government works. I know a scientist. That's more implausible to me than the alien spacecraft thing.
Listen, I think you have an argument there. I do. I think about that a lot. Like how many people, when you think about like the conspiracies and stuff, how many people would have to be in on it with not one fuck up, not one person you forgot to kill because they weren't going to listen to your blackmail, right? It gets tough.
Too much money to be made for it to not, to be kept secret.
It gets
Government
tough.
Can't keep stuff secret. It's just ludicrous. And you got to ask yourself when you hear someone say these things, what's in it for them?
No,
what's in it for someone who can testify before Congress that someone told him he's seen their cousin had a friend who was in the room during an alien autopsy? Okay, I mean, come on.
Did you see our recent podcast? I feel like you watched it. You might have watched it. We were dealing with that. Can I borrow you for an extra 15 minutes? We're having such a great convo, Lawrence.
I'll give you 10. 10.
250. All right, 217.
5.
218.
No.
All right. Well, we're definitely gonna have to bring you back and everything.
Okay. Yeah.
But
I'm sorry. I do have an event, and I have to be.
Oh,
I
know.
have to do something before that. It's just essential.
I feel you 100%.
I mean, I would love to spend another hour here, and I'll come back.
I know.
You'll fly
we're
me
gonna
back
have to.
first class, and I'll be
Fuck
back.
Yeah, we'll do it. Yeah, well, you'll pay for it.
Yeah.
Anyway.
Okay. Yeah.
But what's the when you go to write a book, because you've written a lot throughout your life, and you've done it like we've focused a lot on your whole focus on something coming from nothing. But when you've done it across the board, like you've done a lot of different types of topics, and you've written
I like to think
a ton of papers. How do you decide to sink your teeth into things? Because it seems like your interests scientifically span almost the entire span of it in a way.
Well, they do. Everything interests me. And so I do stuff because it interests me. That's the final answer. I mean, I don't do, and all scientists are that way to the first part. I'm not trying to save the world in my science. I do stuff that I like. And the world, how could you not be interested in everything that's going on?
I wonder that too. And but when I was a kid, I wasn't.
People ask me, how can you? And the answer is, how can't you be? And so I like to think I'm motivated I'm motivated in my science, and what do I think will address the most fundamental unknowns in the universe? That motivates me there. In my writing, I try and think about what might interest the public in thinking about the amazing features of our world. And so that leads me in a lot of different directions, and that's why I've written a lot of different books. So it's easy to write the same book over and over again. I know people who've done it, and I know you mentioned one or two people here who've done it. And
I think I'll go back against that. I think Michio's written about a lot of different things.
It's all anyway. Let's not go in there. Let's go. He has equally authoritatively. Anyway, but
it's not like that. Come on.
Anyway,
he's a good guy.
Anyway, he's a nice guy, and let me say that. But what I try and do is pick a topic that I know something about, but that I may not know a lot about. So for me, it's a learning experience often, as well as, and so that's one way I can ensure that the subjects are different. If I reach beyond my comfort zone. I mean, the climate change book, I'm not a climate scientist.
Right.
But my thought was, if I, as a trained physicist, cannot explain climate science in a way that people can understand it, how can I expect anyone to? And so that was, and it was a great, and the pandemic was on, I had nothing else to do. I wrote that book in 10 times more quickly than any other book I've ever written, because I had nothing, 18 hours a day, I had nothing to do. But that. I had no interruptions, no travel, no nothing. But and the Star Trek book came out by accident. I was when I taught at Yale, and I went in New York often. I was talking to my editor from my previous book, and her daughter was a Trekker. And she said, "What about?"
Is that what they call?
That they used to call them Trekkers. I don't know what they call them anymore.
Were you a Trekker?
You first be Trekkie.
Trekkie?
No, I wasn't anything. I watched every episode of Star Trek when I was younger, but I also watched Bonanza and everything else. I just
William
watched a lot.
Shatner believes in aliens, by the way.
William Shatner and I have talked many times. You can watch our podcast together.
Oh my God, I got to see that.
Yeah, it's a great.
I didn't know you had that.
Oh yeah, Bill's come on a podcast. We've been together.
That's awesome.
He's my pal. And
so you're still friends. You disagree and you're friends. Look at
well,
that.
you can disagree with
Love
people.
That.
And of course you can disagree with friends. My friend Christopher Hitchens taught me that a lot. But Bill is amazing. So he's a hoot. There's no doubt about it.
Yeah.
We did it. It doesn't matter. I won't tell you the story. Next podcast, I'll tell you the story.
Okay.
But what were we talking about before you so rudely interrupted me?
Yeah, I know. I'm sorry. I got you off that. You were talking about the Trekkie versus...
Oh, Trekker, yeah. It used to be called Trekkers, Trekkers. But she said, what about the physics Star Trek? And I laughed, and I took the train back to New Haven. And I started thinking, well, how would I make a transporter? And then I started to think of all the fascinating science you could, And then I thought, I don't want to write this book because I don't want to alienate like 100 million Star Trek fans. I don't want to write a book that says this is wrong, this is wrong. I did agree to write that book, and then I thought, how can I do that? It took me a long time when I realized, well, what I can do is I can take something on Star Trek that resembles something in the real world and talk about the real world. So I can use Star Trek as a hook to talk about the physics of the real world, which is far more fascinating than the physics of Star Trek. So I talked about time travel, talked about warp drive, I talked about lots of different things, transporters, and I use it as a hook because people are intimidated by physics. If you go to a party and you tell people you're a physicist, they'll say, "How about those Yankees?" Okay, And whereas if you say, but what about time travel or warp drive, and then people they don't realize they're interested
Now
in
they
science.
perk up. Yeah,
then they perk
you're
up.
right.
So use those as hooks as a way to talk about the sciences. And so I try and think of ways that I might reach the public in ways that they're interested in that allow me to talk about fundamental science or science of interest. So lots of different ways, and that's really the origin behind the 12 books I've written.
See, that's huge, though, because what you're talking about is the difference between simplicity and complexity in a complex world, because you have to be able to explain it to the fifth grader in a basic term to get them to want to go deeper. And I think that's the biggest problem a lot of us had when we were teenagers in high school. They didn't really do that,
Well, it's also a challenge. Einstein said you don't understand it if you can't explain it to a fifth grader. And I found many times in writing books that I thought I understood something till I tried to explain it in a book, and then I realized I never really understood it.
Wow.
And so that's fun for me.
That's profound.
Yeah, it's so profound that I think it's a good way to end this episode.
Yeah. All right. I'm catching. I got one more question for you because you touched on it earlier. But have you done any work at all in the past that you're allowed to talk about vis-a-vis maybe consulting with NASA?
I mean, there's nothing that I've ever done that's classified.
Okay.
So there's nothing that I've ever done that I can't talk about.
So have you consulted with NASA?
I have. Yeah. Well, I mean, what do you mean consulted NASA? I've have NASA grants.
Whoa.
I've also DARPA, which is a Defense Department agency, asked me to and a not friend of mine from the Nobel Prize to look at various proposals for basically. Anti-gravity devices and show they were all wrong. Okay, I mean, so yeah, but
show they were wrong.
Well, I didn't. They want to know if any of it was on different things, but it was basically asked us to look at crazy proposals, and we looked at them and explained why they were crazy.
When was this?
20, 30 years ago.
You think all those sharks that are biting people might be DARPA sharks? That's like the working theory we have now.
I don't know. Anyway, I don't know. But so I've never had. I was offered a job at Los Alamos, and I had to get past a security clearance back then, but I didn't take the job. Okay. And no, I no interest personally in doing classified research. That doesn't mean I don't think people shouldn't do it. I just myself wasn't interested.
Well, why do you think NASA? Obviously, like in the 60s.
And NASA isn't. When I talk about classified, NASA isn't really classified. I'm talking
it
about
isn't really.
No, NASA's a public government agency that every now and then NASA
their
will
work.
Listen to me for a second.
Now
and then NASA will used to with the space shuttle send up satellites that were Defense Department satellites, and so that mission was classified because they were working for the Defense Department. But NASA is not an agency. The whole purpose of NASA is to try and be open. In fact, that's why they had a commission that explored all the claims of UAPs. And recently, as you may know, although it doesn't get as much publicity as some guy talking about Congress about his best friend's wife's brothers, they just you can see it on the internet. You watch the NASA report on UFOs, and they'll say there's no evidence.
Wait, NASA said this?
Yes.
When did they say this?
You see, that's the point. It's not about 2 months ago.
Really?
It was headed by a friend of mine. A guy I've written papers with, David Spergel, who was at Princeton, is now at.
But could they just be covering it up?
No, the whole point is: do you not think that they would want to be more famous? You would have heard of them. If they wanted to be more famous,
but
they could have said
they don't have a choice.
There it is.
Okay. NASA report finds no evidence that UFOs are extraterrestrial.
September 14th.
NASA's independent study team released its highly anticipated report on UFOs on September 14th,
And believe me, they would have loved to find evidence for aliens.
All right, hold on. Scroll down where it says bottom line. Bottom line, the study team found no evidence that reported UAP observations are extraterrestrial. But Lawrence, I need facts here. I need data. This is just an article. You know what I mean?
Well, the point is, it'd be great. Find me some data that they're extraterrestrial.
And that's fair. I do
and there
think
isn't
that's
any.
fair.
And the fact that there hasn't been for the last 60 years, in spite of all the claims, is good evidence that there isn't any.
Well, why have we lost interest at NASA and in pop culture and things and I don't mean to say it like oversimplified, but as simple as going to the moon like we did.
Well,
50 years ago.
NASA hasn't lost interest in it. It's still doing it. In my mind, it's largely a waste of money, but it's still.
Why is it a waste of money?
Because it involves people. I mean, I shouldn't say it's a waste of money. I think the moon is actually a reasonable destination for NASA to consider going to. But what you have to realize when it comes to science, the best science NASA doesn't involve putting people into space. And there's a simple reason. If you put a person in space, 99.999% of the cost is devoted to keeping them alive.
Yeah. It's a
Okay,
lot.
you put a rover into space. As I like to say, you could send a rover to Mars for the cost of making a movie about sending Bruce Willis to Mars. Okay, and so on the whole, we can do so much more science and so much better science without putting people in space. That doesn't mean we shouldn't put people in space. There are other reasons to put people into space: adventure, national priorities, national esteem, and maybe to some extent. Industrial arguments. But from the point of view of understanding fundamental science, the best science NASA's ever done and probably will ever do doesn't involve humans.
Well, do you think that's why
It involves humans on the ground, not in space.
Do you think that's why part of it is now it's moving to a lot of potential private research with that? Like you see Jeff Bezos trying to do this stuff?
I'm all in favor of people spending their own money on that kind of thing, private money. And I was involved in a Russian billionaire spent a lot of money trying to think of a way to send an object to a nearby star at a fair fraction speed of light. And Stephen Hawking was on the program, so was I. It's called Breakthrough.
Which billionaire?
Yuri Milner. And he's funded Breakthrough Listen, Breakthrough, and I was on Breakthrough Starshot. And I thought it was really neat because you'd explore the limits of technology. Unfortunately, at every meeting, I became more pessimistic about being able to do it. But I'm happy to have billionaires spend their money on that kind of stuff.
All right, got it. Well, Lawrence Krauss, I really appreciate you coming here.
Thank you.
Where can people get the best information about you? Twitter?
Twitter,
I'll put all the links
misinformation
down there.
and information you'll find on Twitter. You can look at my website, lawrencemkrauss.com, or the Origins Project Foundation, which is the foundation I run.
And you have the podcast, too.
And exactly, I was going to say the podcast, which you can see ad-free on our Substack site, Critical Mass. You can go to YouTube and look at the Origins Project Foundation.
Yeah, you got a lot of amazing people on there.
Yeah, I'm really lucky, and including Bill Shatner. So you see.
Oh yeah, see, I gotta go see that. That's awesome.
Yeah,
but listen, thank you so much for doing this. I definitely got to do this with you again. You are entertaining as hell, man.
Thank you very much. It's been a lot of fun.
Everybody else, you know what it is. Give it a thought. Get back to me. Peace. Thank you for watching the video, guys. If you haven't already subscribed, please smash that subscribe button and check out this clip's full podcast episode by clicking here